Welcome back. Today, we're going to build a secure bridge across the internet. We're taking a really detailed, structured look at how two powerhouse networking protocols, GRE and IPsec, team up to solve a problem that, honestly, neither one of them can handle on its own.
So here's our game plan. We're going to start with the core problem, then build up the solution piece by piece. We'll follow a single packet on its journey, dissect its anatomy, and then get into how you actually set this all up and, prove that it's working.
All right, let's get right into it. To really get why we combine these two, you first have to see what's wrong with them individually. What are the limitations when you try to use them solo? This right here is the fundamental challenge. Imagine you've got two offices, right? And you need to connect their private networks securely over the big, scary public internet. But, and this is the tricky part, you also need them to share complex routing information so they act like one big, seamless network. It's a classic puzzle for any network engineer. Okay, so here's the breakdown. On one side, you've got GRE. It's awesome. It's like this super versatile cargo container that can carry pretty much any kind of traffic, including something called multicast. Now, think of multicast as an announcement that goes to a whole group of devices at once, which is absolutely essential for routing protocols like OSPF. But GRE has a huge flaw: zero security. It's like sending your data on a postcard for anyone to read. Then you have IPsec. IPsec is a fortress. We're talking ironclad encryption, authentication, data integrity, the whole security shebang. The problem? It was built for one-to-one communication, so it just can't handle those group multicast announcements that routers need to chat with each other and share their maps. So one is flexible but wide open, and the other is secure but totally rigid. You can probably see where this is going. Let's look at how we combine them for a solution that really does give us the best of both worlds. And here it is, GRE over IPsec. The idea is so elegant and simple. We take that flexible GRE tunnel with all of its precious cargo, and we wrap the entire thing inside a secure IPsec tunnel. We're basically putting our versatile do-anything cargo box inside an armored truck for its trip across the internet. This really shows you the power of layering in networking. First, GRE acts like the packer. It boxes up everything, from your regular user data to those super important routing updates. Then IPsec comes in as the security guard. It doesn't even look inside the box. It just takes the entire GRE package and wraps it in a thick layer of encryption. What you get is a single secure tunnel that can carry anything you need it to. So we've got the concept down, but what's it actually look like in practice? What really happens when a packet of data leaves a computer in one office and travels through this tunnel to another? Let's trace its path, step by step. You can see it's just a clear, logical, four-step process. It's like an assembly line for your data. Step 1, the original packet gets wrapped up by GRE. Step 2, that whole GRE packet gets encrypted and wrapped up by IPsec. Step 3, it gets sent out onto the internet. And then, of course, the router on the other end just does the whole thing in reverse. It decrypts the IPsec layer, then unwraps the GRE layer, and out pops the original packet. Totally safe and sound. To really make this stick, let's build one of these packets from the ground up. We're going to visualize it, adding each layer one by one so you can see exactly how this thing is put together. It all starts right here with your original data. This could be anything, really: an email, a file, or one of those important routing updates we talked about. This is our payload, the thing we need to protect. First thing that happens, GRE steps in and encapsulates it. It slaps a GRE header on the front, basically packaging our payload and getting it ready for the tunnel. This is us putting our stuff into that versatile cargo box. Okay, now for the security layer. IPsec comes along and wraps everything we have so far, the GRE header and the original packet, in its own secure header. At this point, everything inside is completely encrypted and protected from prying eyes. And for the final step, to actually send this thing across the public internet, we add a brand new outer IP header. Now, this is the really clever part. This header only contains the public IP addresses of the two routers at either end of the tunnel. This means the original private IP addresses are now buried deep inside, totally encrypted and hidden. To any network in between, it just looks like normal traffic between two routers. And just like that, our packet is secure and ready to go. So this all looks great on a slide, but how do you actually make it happen on a real router? And maybe more importantly, how do you double check that everything is working the way it's supposed to? The setup actually follows a really logical, structured flow. It's a three-step dance.
First, you build the GRE tunnel interface on both ends. Second, you give that virtual tunnel its own private IP addresses, like you're creating a new little private link. And third, you define your IPsec security rules and tell it to protect all the GRE traffic. Build it, address it, secure it. Simple as that. And once it's configured, you've got this simple but super powerful checklist to run through. First, check the basics. Is the GRE tunnel itself even up? Second, has IPsec done its thing and established what's called a security association? That's just the fancy term for the agreement on encryption keys. And third, the real acid test. Have your routing protocols like OSPF actually become neighbors and started sharing information across the tunnel? If you can say yes to all three, then congratulations, your secure bridge is officially open for business. Okay, so we've been through the problem, the solution, the nitty-gritty of the packet structure, and the configuration. Now let's pull back for the big picture. Why is this specific combo so incredibly important in the world of networking? Well, the benefits are huge. This isn't just some clever workaround. It's a foundational networking technique. It finally lets you run dynamic routing protocols securely between your sites, which is something IPsec alone could never do. You get the whole security package: confidentiality from the encryption, integrity so you know the data hasn't been messed with, and strong authentication, all without giving up the flexibility that your network needs to run smoothly. And really, this quote says it all. For a long time, network designers had to make a tough choice. Do you want that smart, dynamic routing, or do you want top-tier security? You couldn't really have both. GRE over IPsec completely changes the game. It says, no, you don't have to compromise. You can have it all. And that brings us to one last thing to think about. GRE over IPsec was and still is a brilliant solution, but technology never stands still, right? As our networks get smarter and more automated with things like SD-WAN, and as they stretch out into the cloud, you have to wonder, what's the next evolution? What will the next generation of secure, flexible, and intelligent tunnels look like? That's the next big puzzle we all get to solve. Thanks for joining me.